This is Chapter 9, Section 2, and we're still doing formulas in area and perimeter, but this time we're going to talk about more circular-looking shapes. The first one is a regular polygon, and this is going to be new, so I'm actually going to start with this. That way, if the video goes too long, I'll just stop, and we'll go over the circles tomorrow. So, when you see a shape that looks like a polygon, remember we spent all that time on polygons, regular and irregular. We're going to be able to find the area of the regular polygon applying a bunch of stuff that we've been learning. So the first thing I want you to do is just put a box around your area formula that's on the page there, okay? It is area equals 1/2 little a times p. The p stands for the perimeter along the outside. That's easy. The a stands for a new word called an apothem. Okay, kind of fun to say, a little silly. The apothem is the center, is the distance from the center straight perpendicular to a side. And they drew it here in the picture for you. Okay, and they also defined it for you. In step 1, it's already done for us on this example problem, we're going to be asked to find the area. We're going to recognize that it's a regular polygon. So the first thing that we're going to do is we're going to write our formula. A equals 1/2 little a capital P. Remember, the little a stands for apothem and the capital P stands for perimeter. What happens is we realize that given the information that's given in here, the only thing that's given here is that one of the sides is 10, which does not seem like enough information. So we're going to go back to our picture, draw a picture, recognize that with a side length of 10, we can find what we call the apothem. The first thing we're going to do, written for you here, is we're going to draw a figure and find the measure of what we call a central angle. Central angle, defined here in the box, is the angle that forms the triangle that creates the side. And it's always going to be 360 divided by the number of sides. In this case, since we have 360 divided by a hexagon, which is six sides, we get a central angle of 60 degrees. So that's what we draw first. Then you're going to draw a second, that's what the arrow is noting, hexagon. This time you're going to go ahead and add your a, little a, and we have a right triangle with a 30-degree angle. We take that 60 and divide it by 2 and get 30 degrees. So there is a lot of steps in step 1. So what we have so far is this red triangle here. We have a red triangle. If you want me to draw it off to the side, if that helps you, go ahead. We put the 5 there because if the side length is 10, then we know that half of that is 5. We also need to find the apothem given this 30-degree angle here. So you have a couple choices in step 2. Step 2, you can either use 30, 60, 90 triangle. I'm going to do that off to the side over here on the right. The 5 is the short leg, A is the long leg. So A is going to equal the short leg radical 3. We could do it that way, or we can find the apothem by following the steps written here. Let's start by writing a tangent ratio. What tangent ratio can we write if we have a 5, an apothem, and a 30 degrees? Well, for this reference angle, we have an opposite and adjacent, so we can write tangent 30 equals opposite over adjacent. Solving for our unknown, which is the apothem or the adjacent side, we're going to take 5 and divide it by the tangent of 30. When you do that, you're going to get a decimal that's equivalent to 5 square root of 3. What you should get on your calculator. So you can either write that 5 square root of 3, or you can just go straight to your formula now, which is step 3. So we're going to take the a, which we solved for is 5 radical 3. We also know that it is the five divided by tangent of 30. That's what we got in the last step, okay? We can just plug that right in, just like it is, into our formula. So we're going to write the formula for an regular polygon. We're going to get capital A equals 1/2 lowercase a times perimeter. and we're going to plug in that 5 divided by tangent of 30. The other thing that we're going to do is recognize how to find perimeter. Perimeter, remember, is all the sides added up, and since we have 6 sides and each of them are 10 units long or 10 centimeters long, we get a perimeter of 60. And I can plug that right in there for the perimeter. Okay, plugging that in your calculator straight through the way it's written gives you an approximate value of 259.8. And since we are doing area and we're rounding, we're going to put a square unit there and an approximate symbol to show that we're rounding, and that's the answer. Okay, I'm going to finish by doing 2 more example problems. We're going to do 7 and 9. I want you to try number 8 on your own, okay? So let's look back up at our notes. What is step 1 when we're finding the area of a regular polygon? Step 1 is basically to make this triangle with the central angle. So if I'm going to do it for this picture, I'm going to draw the central angle from the center, make a triangle out to the side that's given to me. Since this one's given to me, I'm going to draw it this way. The central angle of, let's count how many sides there are, 1, 2, 3, 4, 5, 6, 7, 8, of an 8-sided figure is given to us, let's do this off to the side, by taking 360 and dividing by 8. Doing this on our calculator gives us, if you want to abbreviate, CA for central angle, a central angle of 45 degrees. So now, let me take a different color here and put it in my picture. So this big triangle here has a central angle of 45 degrees. Now I always like to redraw it vertically or straight up and down. It's just easier to see this way. Because now you're going to see that your apothem is your height, if you will. 12 centimeters is the full length down here. Okay, that's the side of the triangle. I've just flipped it up. That makes that a 6. And my central angle, which was 45, needs to be divided by 2. So I'm actually going to put right here 22.5 degrees. So you're always going to take your central angle and divide it by 2 to make your right triangle. Now we can see that we have a tangent relationship for 22.5 degrees. So we can write tangent 22.5 degrees equals opposite over adjacent, or 6 over A. To solve for A, we're going to divide 6 by tangent of 25. I'm going to recommend you don't get this as a decimal at this point. You just plug it right in, just like this, just like I did in the example problem. Now we can write area equals 1/2 apothem times perimeter, which equals 1/2. Apothem is 6 divided by tangent of 22.5. And the perimeter is 12 times 8. Which when we put that in, we get 96. Plugging that whole thing in on our calculator gives us approximately, give me 1 second here, 695.3 centimeters squared. Okay, I'm going to finish with number 9. Number 9 is asking for the area of a regular hexagon with an apothem of 3. So what this looks like if I draw my right triangle is, let's pretend that this is the triangle of a side of the hexagon. We don't know what the side length is. Let's call it S. We don't know what it is, so I'm just going to call it S. This is as if I were drawing a hexagon and I'm only drawing a little portion of it because we really only need the triangle part of it. The apothem is given this time, so let's go ahead and label that. They're telling us what it is. They're telling us it has a units of 3. But we're still going to find the central angle because what is unknown is this x here, which when we double it will give us the s, or the side length, for us to find the perimeter. So what is the central angle of a hexagon? Well, we've already done that one. We did it up above. The central angle of a hexagon is 60, so that means that the angle involving our right triangle is actually 30 degrees, and that's what we put there. So now we can find our x, which is half of our side length, by doing tangent of 30 equals opposite over adjacent. So half of our side length is 3 times the tangent of 30. So since we have to double that, in order to get my side length is always 2 times that x I'm going to get 6 times the tangent of 30 for my side length. Okay? Now, to finish this one off, let's write out the actual formula now. Let me switch colors back to black here. We're going to write A equals 1/2 times the apothem times the perimeter. In this problem, the apothem is 3. What is the perimeter? Well, if my side length, which is 2 times that x we just found, okay, you don't need to memorize s equals 2x. I'm just trying to show you how we doubled that to get our side length. We took 3, times it by 2, and that's how we got the 6. Well, what are we going to do with the side length to get perimeter? Perimeter is how many sides there are, 6, because we have a hexagon, times the side length. So when you multiply 6 times tangent of 30 times 6, you can just simply write your perimeter. And let's put this in over here as 36 times the tangent of 30. This way we only have to touch our calculator one time, because a lot of this math you can do in your head. For example, 6 times 6, okay? 6 times 6. Or 3 times 2 we can do in our head to get our 6 originally. Once we type all of that in on our calculator, you can practice if you want. We get approximately 31.2. Let's go back to my picture, or my words. My units are meters, so my answer is 31.2 meters squared. Okay? All right, that's all for tonight. We will definitely need practice on these two sections tomorrow, and probably a little bit more on Wednesday. And I will see you guys in class.